Hi, Viper Chemistry students. Let's talk about how you write formulas for binary compounds. Okay, so if you know the name, how would you write the formula? And so what happens is, you will begin to know like what charges elements have, like lithium being an alkali metal always has a +1 charge, and oxygen is in group 16, and so it's always going to be 2 minus because it's going to want to reach the octet rule to be like a noble gas. But anyway, knowing those things and kind of having some insight into that, then you can literally, the easy way to write the formula is just to simply switch the charges. Okay, this is the cation, this is the anion. If you take the charge and make it the number of the elements. And remember, subscripts represent the number of the elements. So we're going to have two lithiums because it's a 1 plus charge to match up with the 2 minus charge of the oxygen. And so that's why that works. So that's kind of a neat little system. But anyway, here are the rules. Write the symbol for the cation and then swap the charges. And if you do that and practice that, you will learn that will actually result in the actual formula itself. So here's a case. Here's an example. Magnesium oxide. So magnesium's +2. How do we know that? Well, it's a group 2 element. It's an alkali earth metal, and then oxygen is in group 16. So it's always going to be a 2 minus. And just swapping the two gives us 2 on both sides, and you just cancel those two, and that results in just MgO. So there's no reason to write Mg2O2. Okay, so that's why the charges just sort of balance each other. They add up to 0, and so that's what you want to have happen there. They are neutral in charge. Okay, so as long as they're neutral, then um, elements would form compounds that way. Okay, so here's an example of a similar situation here. Potassium is a +1, oxygen is -2. So if we switch the two charges and make them the subscripts, which represents the formula numbers, then we would have K2O. So the 1 goes here, the 2 goes there. Now we're going to have 2 positive charges, and we're going to have just 1 -2 charge, but they add up together and equal 0, and they neutralize. Let's see. I'll say, here's some practice. So what about lithium sulfide? Lithium is a +1, sulfur is a -2. So it's going to be lithium subscript 2s. Okay, what would you predict about calcium bromide? Calcium's a +2, bromine's a -1. Switch them, then there's going to have to be 2 bromides, so it's going to be calcium bromide subscript 2. Okay, so that's the idea that you could um, uh, practice that, and in your worksheets you'll get plenty of practice, and I'll put the keys up so that you can check your work. Aluminum bromide. Um, aluminum is a +3, so no, and that's going to be a question that comes up, like how do we know if a metal has more than 1 charge? And that's a good question. But I think once you work with it, and I think there's some charts that we'll have available for you, you can check on that. So here's lead 2 sulfide. So this is going to be a 2 plus. Sulfur is a -2. So it should just be PBS. And there it is, PBS. Okay. So once you kind of catch on to that, and you're familiar with the charges, like what their values are, this whole thing comes together pretty easily. We're just working with binary compounds right now, so we'll start simple. They do become become a little bit more complex as we go, but it's very doable. Oxide's a 2 minus. This is iron 3, so we'd have to put the 3 below as a subscript to the oxygen, and a 2 as a subscript to the iron. And there we have iron 2, iron, Fe with a subscript 2, and O as oxygen with a subscript 3. All right, guys, thanks for watching. And the idea is to keep practicing. And thanks for watching.